Hello hackers, welcome back to Rust for Hacker series. This is going to be the 12th project in our series, and today we are going to explore Rust a bit more in depth, and we'll be making a tool to implement steganography. So before developing our tool, a bit theoretical stuff. What exactly steganography is? It's a technique of hiding secrets within an ordinary or non-secret file. That's very formal definition. Is basically you are hiding something inside an image, audio, or video file. So a normal human can't read or hear what you are hiding inside that. The core principle is just it's called carrier files. A carrier file could be anything like image, audio, video, or even a text file. I did miss the text file here. So you can basically hide your message inside any of these carrier files. So there will be this steganography tool should support hiding message and extracting message. Then only it will be useful for both parties. Both parties will have the same tool, and that uses the same technique to extract and hide messages. So they hide message and send the carrier file to the other person. So the other person will have the same tool that helps him to extract the hidden message. That's how it works, and there are different techniques behind this, and we are going to explore LSB manipulation. It's called least significant bit manipulation. So we are going to teach the LSB bits to hide our messages. And there are that other techniques are metadata injection. We hide file headers or unused fields. Hide our data inside these fields. Or there's another one method called append data, add secret data after the end of file. And the other one is frequency domain. This is normally work closely with audio files. And text steganography. Text steganography uses white space. Anyone can. It's very easy to implement. You just open up a file and type something and change the font color to white. Yeah, that's a stego technique. And when some normal person opens a file, so if he's going to be a very technical person, definitely he will notice because the cursor will be end of the file. But if it's a normal person, yeah, definitely nobody's going to. At least at first sight, nobody's going to notice that. So how it works, our technique, the technique that we are going to use is LSB manipulation. How it works is we take each byte from the image, and it's going to be 8 bits long, and inside the 8 bits we are going to take the least significant bit, and we do apply our algorithm into that. Then that's in that area we hide our secret messages bit one by one. So yeah, definitely, because it's going to be LSB manipulation, it won't be detectable for normal human eyes. There are challenges, like if your message is too high, you have to use big carrier files. So how it works is we are going to take pixels. Imagine that it's going to be like this, and suppose our secret message is high, and this is actually this is equivalent of H, and this is for I, binary equivalent of this one, and ASCII equivalent is 72 and 73, and then we take the red pixel and replace this bit with our secret bit. So the first one is 0 here. We take the 0 and put it here, and the result will be 254, but that doesn't make any change on the entire picture. We do the same thing for the green, and of course for the blue. So in short, how much data we can hide is, for each RGB we can hide 3 bits. So just imagine how how much we need for bigger secret messages to hide. Yeah, definitely we need corresponding carrier files with bigger size. And this is the core logic that we are going to implement, and I added the technique of this one. This is a way that we are going to access the pixels, and 00 means red, 01 means green, and 02 means blue. And the basic logic is we are going to, and this algorithm is very famous. It's not my algorithm, it's there, and in every language you can see people are using LSB algorithm using the same technique. We are just, and we are applying an AND operation here, and just note that this is bitwise AND, it's not the and conditional operator. So the bitwise AND operation on this one, this is in binary this number. So what happens here, after ANDing this, we OR our secret messages bits. That's what we see here. So as an example, from H, since it has 8 bits, we take each one of this and apply the operation here. So how it works, as an example, as red is 255, then we AND it with this one, and so internally it's going to convert this, and of course the last 1 and 0 is going to become 0, so the result will be this. Oops, sorry, where it was. I did undo something. Yeah, not here, this one. So when we are doing AND operation on this bitwise AND on these two, the result will be this, because everything else is 1 up to 1. As you know, 1 and 1 is always 1, and 1 and 0 is always 0. That's why we are getting this one. So the number is 254. That doesn't make any change, any visible change on the image that we are going to make use of. So after that, we do an OR with 0. Why 0 means, here the example I shown before, I said it was high, so the first bit of the H on the 8-bit sequence is 0. That's why it works here like this. Again, it converts to ORing. OR is just it's just like true or false. So the last bit is 0 and 0 or 0. It always returns 0. 1 or 0 is 1. So you can see all this. The result of this one will be this. So in this case, an example case, this doesn't make any big changes, but definitely these values will be different when doing it real time. But that doesn't make, because we are using the least significant bit, and that doesn't make any impact on the appearance of the file. So that's it. Now we move to the coding part, and for this one actually we need a package called image from Rust, and we can search it here, image. Yeah, we're going to make use of this image package. So let's start our project. cd cargo new stego. Yeah, I can give any name anyway. Let's cd stego. We are going to open our IDE. So the first thing you have to use is just copy this and add it to your cargo terminal file dependency area. come here. Better always try to build before we start. Oh, sorry. Oh, Rust is doing something behind the scene. Let me check. Okay, let it run there. And here what you are going to use is that image that we loaded now, and I think we just need the RGB image part of that. We are going to make use of functions inside this. Let me check it get lock or yeah, it is building. So definitely this is one of the biggest I hate this thing in Rust. It takes a lot of time to compile. Yeah, but they are saying that they compensate it in runtime. You will feel the real difference if you're coming from Golang or some other languages that compiles faster. Yes, somehow it is getting closer, so we just try here. So what we need here is we should have two methods. One is hide message, and other one is going to be suggested as far as extract message. For the hiding message, we need to have the reference to the image, and let it be an RGB. Yeah, definitely should be an RGB image, but it should be a mutable reference because we have to do a lot of work on that. So it should be a mutable reference, and yeah, once we get the image, then the next thing is we should have, yeah, it suggested that we should have the message. Yeah, these are the only things that we need for hiding our data inside the message. So the next is we have to do the implementation in a Rusty way. So getting the bits collection, like what to say, we have to convert your message to the zeros and ones first. For that, we are going to make use of one of the functions in Rust called flat map. Yeah, I will show how to do that. Let message bits, you can say bits, that could be message. We're going to iterate over all the characters. Then because we need a continuous collection of zeros and ones. So for that, there's a technique called flat map. Normally, there's a function called map, and there's another one called flat map. The basic difference between these two is map, when it's iterate, it definitely it is working almost like flat map. But what flat map is doing is the result of the flat map is a flattened structure. Suppose if you do in map with a list inside the list, so the result after the operation will be kind of list inside the list itself. But in a flattened map, it's going to be a continuous array kind of structure, so we can make use of that. You can iterate over easily after getting the flat map result. So I'm going to make use of flat map here. So the flat map, what we are going to do is we have to iterate over each characters inside this message bit. So for that, yeah, it's going to be a closure anyway, because we are going to make use of the flat maps closure method to iterate over every characters. So, and actually that end goal is we have to get the bit sequence, like it has to convert everything to 8-bit sequence of characters. Characters means 8-bit sequence of binary of each characters inside our message. So for that, I'm going to make use of the same thing. C just represents character, and what you can say is you can make use of this and this here. It's going to be a kind of function. So for that, and we can make this format, and format has yeah, it is suggesting that. So let me check. Yeah, it's going to create a binary format, string kind of structure. Actually not string, it's going to convert to binary, and it's going to be 8-bit sequence. That's what it just 08 means. If it's not going to be 8, it's going to be filled with 0. That's the meaning of this one. So now we have the converted binary format, and the collection should be and we have to collect it to our message bits. So after doing the collection of all characters, the result is going to be like corresponding. Suppose if our message is as just like the one I showed in PowerPoint, if it's high, is going to be like corresponding binary sequence. First is convert the characters to ASCII characters, then convert that ASCII number to binary, and then take that number binary with 8 bits, and the flatten map method will give us continuous sequence of the entire message in zeros and ones. That's what this thing is doing in using Rust. This is a Rusty way of handling this. There are other performance oriented ways of like bitwise shift operations that you can try yourself. I just want to show how we can achieve this, and to show some methods available for easy operations like this in Rust. So the next thing is we have to iterate over every pixel in the image for, I say, pixel itself, and so let's say pixel in our reference. Then now the next thing, actually in a normal, if you see other languages, you have to do 2 loops, like one loop inside another loop, like every pixel, then every message bytes. Here there's an easy way to do that. It's called, after now we have this one has the zeros and ones as a kind of characters of 8 bits. So so what we can do, is there any bracket issue? Yeah, here. So what we can do is we can do an operation called message bit dot next. This will help us to, this will internally help us to start from the 0, but it points every iteration on the outer loop, it points to the next till the end of this collection, because it's a flattened collection, so it is easy to do this operation. So every time when you do this one, we are going to so yeah, one more thing is See, if you check here, this is going to be an option. So if you are following this series, you already know what exactly how to handle the option. So what we are going to do is we are checking a safety check here, if using the if let, and some of the bit, and some of bit, this one. Okay, I'm just suggesting some codes that works. In fact, oh yeah, let me take the code suggested by that. Let me see what exactly it is. Oh no, this is not something that I explained in the beginning. So what I'm going to do is I'm going to do the same thing that I mentioned. Yeah, this operation is correct because this is equivalent to the hexadecimal number I shown in the PowerPoint. So this will work definitely. So we have taken the first part, the red pixel part, and we are doing the AND operation, and then we do, I don't know whether this will work because we need to, yeah, I think even, but for the safety I'm going to convert this to just to confirm that it's going to be like a 2-digit, and it's going to be binary number, and then we unwrap it. But unwrapping as U8 because it's going to be byte. It's going to be bit operation. So I don't know. This is going to complain. What some complaints is there. Anyway, you don't need this bracket and this bracket. So what exactly the complaint is now? Immutable variable message bits cannot mutate. Oh, sorry, this should be mutable variable because we are going to do the work on this one. So oops. Yeah, now we have to do the same thing for the green and the blue. And when I'm saying this operation, this is going to work on red. And now we have, oh no, we should be assigning the, I don't think it's a good idea to assign, but for the time being, I mean not for the time being, but we can avoid another variable. Otherwise what we can do is you can you can directly, I mean you can take a value of this first to another variable, and not another variable, this like this for more readability. And after the operation what we can do is we can say pixel, yeah, this will be more readable if you want. Otherwise other method is also so good. It doesn't matter. If you are doing it first time, just try to make it more readable and try to do it like this. So now we got the first one, now the next one. So just now we got the first bit of our secret message. So the next one is going to be the green. So the next bit what we're going to work is on, just say green, and it's going to be 1 here, and remaining everything is correct, and it's going to be 1, just say green. So think that that's not showing any error. So rest, as for rest, it doesn't make any issue. So the next third bit is going to be blue, and of course it's going to be the last one. This part is correct, there's nothing to change, and this needs to be changed, and this is going to be blue. So we now did make some changes to this hiding message. I think this will make the thing work for us. Let me do a cargo format here, cargo empty. So this will format it for us. Yeah, now it is well formatted. So now let us rewind what we did. We just created a flattened map or sequence of zeros and ones here as a collection, converting our secret message to zeros and ones, and kept that in a collection of vector characters. So that from that we were iterating over each pixel in the image, and from each pixel we were taking the least significant bit using the red, green, blue part of the pixels, and we take it and do an bitwise AND operation with this. Then we take our message bit using the message bits next method. So this one will be like this message is going to have every zeros and ones of in our message. So every time when it iterates, it points to the next character inside the string. So this flattened map will have that, as I said, zeros and ones of the message. So this part will work for us. For every pixels, it takes all the messages. But the thing is, you should be aware of the message length that you are working with. If it's going to be too lengthy, yeah, definitely it won't work here. So the next extract message, okay, before the extract, I think I do have the extract message here. Yeah, and again, this is a well-defined algorithm, so we are just trying to do it in Rust. That's it. So for extracting the message, we are just ANDing bitwise AND operation with 1. 1 means it's going to be 0 0 0 0, 7 zeros and 1. So the same concept, we are going to do an AND operation on the LSB bits. Then this is how it is going to work. Once we AND the operation, we get the extract. We are going to get the bit back, the actual message bit back. That's it. So for that we need, again, you have to keep in mind that we are going to operate it on 8-bit chunks. So that 8-bit is very important here. You should always keep that in mind. So just like the other one, we need to pass the image, and definitely the image should be a mutable reference, and yeah, we are going to send a string back to the caller function. And the next one should be not the message, actually the message length. We have to pass the message length, since we are going to we should have a proper break on the operation while it's looping through the bits for extracting the message. So first I'm going to say let mute message, same thing, message. I'm taking the message bits, and it's not going to be a direct string. For the safe part, I'm going to make a vector, So okay, now I just declared my message bits. I had to extract from the image, so the same operation I had to do for pixels in image road pixels. Okay, what is suggested code is, yeah, push pixel of 0. Oh yeah, this one. Okay, but it's not going to be as U8. Instead we are going to make it as a string. So to string, so we will get the corresponding strings of the sequence. This one here, and okay, now we have yeah, this is important. I think it's showing here. Yeah, this is very important here. If message bits length is greater than the actual message length, not actually into 3 but into 8, because we are processing the chunks of 8. So it should be like this. I think I did. This is correct. This bracket is correct. Maybe because I'm not sending. Okay, just say test. Okay. Yeah, it was the rust analyzer was showing because we already mentioned the return value here, but we didn't say any return here. So this is just for the time being. It's not the actual value. We had to send it back. So what we had to do here is, if message length is going to be into 8, then we have to break it. So now we have our extracted bits in the form of strings. Now we have to do the next part. Let just shadow this message bit so you don't get any confusion on that. So what you can do is you can use the concat method. So this will combine all the, this will make a single string. So now we have the binary sequence as a string. So the next thing what we can do is okay, now we need to set our message. Actually, yeah, it should be immutable string new. Then oh yeah, it suggested, I don't know how it's getting this kind of predictions, but this one is really good. This is something we need to do. So what we are going to do is we are going to iterate over the message bits that we got here and till the end of that, but for 8 bit of chunks. That's the method step by is doing. So then after that we are pushing each characters. Actually let us check how it's going to work. Each character from str. Actually this method, how it works is like it takes I'll show you how it works. I don't know whether the character has this option, but yeah, it should be, could make it in a more readable way, like not directly push it like this. Instead we do it in take each byte first. This is a good way. Take each byte, and each byte is from I to I plus 8. Yeah, that is correct, because we are taking 8 bits of chunks. Then let me check this one. Actually there is another method of doing it. Dot pause. We need to convert this to each characters to corresponding, or to say the operation that we are planning here is we have to take every byte and convert to corresponding character, that's the ASCII character, then push that to our message string array. So we will get the message back. For that there is a method called from str_radix, that the one that it suggested now. Let me try that, because that is the method that I plan to show you. That's a new method to learn, in fact. From this one. What it does is, like when you are calling this one, see it takes a string, and the second one, this is the source of our sequence. Then the second one says that is it is a binary, so it is just converting that from the binary to the corresponding characters. This is how we have to fetch it in the Rusty way. I know it's a bit confused, but yeah, when you come to be familiar with more Rust functions, you will come to know this will be easier for us in future. So after that, we can directly push this message dot push. After the operation, we get the sequence of byte, like as a kind of string. Just imagine there's an 8000001 as a complete sequence. Then there will be a corresponding character for that, right? So we take that sequence as a byte, then we convert that to character, then we push that character to our string array. That's the operation that we are planning to do here. To do that, to achieve that in Rust, there are different ways to achieve it. So what I can say here is I already got this byte here. So byte simply, as I say, just say convert to character. So this will do the work for us, I think. Expecting so. So we iterate over these bits, everything using 8 bits. Then we did the push of this character. Oh, one more important thing we need to do is before taking this data, we have to ensure that we are not crossing the boundary. So for that, we say when the I plus 8, either you can say is going to be greater than or greater than the message bit length, you can break it, or we can do less than or equal. For more readability, I can say less than or equal to this message bit length. Then don't break, just do this. So now we just ensuring that it's not going to cross the boundary when it's iterating over the 8 bits of chunks. And I think this will work. Yeah, we have to return this message, so this should be working, but we'll check it. So what should be, yeah, let me format this again. I think this, I mean, when you're hearing this first time, you may feel a bit weird, but believe me, if you code more things in Rust, it will be really easy for you. Anyway, in any language, when you're going to do this, the algorithm is same, so you can do it in different ways. Maybe this is a Rusty way of doing it, like using some of the available Rust functions to convert characters to binary characters, then taking it back again to from binary to normal characters. These are some functions that you can make use of, like from str-radix and what was the flat map collection stuff. These are some Rust specific functions. I wanted to show that here to learn more in-depth Rust. So now we have these two things here. The next thing we have to do is we have to mention what to say, specify our image. Let mute yeah, just say image, just say img, don't get confused on that part. Equal to, going to be image dot open, yeah, image dot jpg, yeah, just keep this image dot jpg for the time being. Now we have, yeah, let message is going to be something different. Hide this for me, and just keep in mind that it's not going to be a message like this, because we are going end of this operation, whatever we are going to give in string, we are going to convert it as bytes and bits, so you can hide anything. Even you can hide a complete binary after converting to, suppose if you have shell code, you can convert that. I mean, you can directly take that to here and convert everything to bits, then do the same operation, doesn't matter. So you can basically hide anything, but again, it totally depends upon the size of the carrier file that you're going to make use of. So now I'm going to say hide message using this, and I'm going to extract the message using this and print it. Yeah, and say the hidden message is this, and there's some errors it's showing. I think it's of the second one for the extract message. Oh yeah, it doesn't allow for okay, for, yeah, we are not doing anything here on the extract message. Actually, it's in read-only form here. So here we are manipulating the image. So for the second one, we don't need the mute, and moreover that Rust doesn't allow, Rust is not going to allow you to send, I mean, use two mutable references. Now what is saying, I don't know, mismatch types. Let me see. Hide message is mutable RGB. It is mute image, and sometimes I completely lost on these things. And okay, it's fine. Mute underscore mute image, right? And now for extract message, it's img reference and message length is correct. Wait, saying, did I miss something? When I'm saying image, it comes here and it's a mutable reference, and this is an immutable reference. So now this one says that it is not matching. What it could be? I expected mutable references. Oh, I'm doing something wrong? I'm not getting it. I lost on this. Okay, let me build it. It's going to say anything. Anyway, it's going to say the same thing. So let me come out when I'm looking into this one. Index out of ones. Yeah, something else is there. Some other things are there. Expected image buffer found dynamic image. Okay, we didn't do any found dynamic image. We are pass. Okay, got it. Okay, I know what it is saying. So we have, after the there's a method in this one. We have to convert this to RGB8 to make our image as normal one. So like, see, now it's gone. The other one, when you are trying to unwrap it, actually it's another type is called dynamic image type. That is, even you can make use of that for different operations, but here we try to do the RGB operation, so we have to convert that to RGB8. So yeah, this is how we have to learn stuffs. Sometimes you completely lost on the I hate the REST compiler errors. It's very difficult to tackle the errors, but yeah, now it's somewhat I'm far better than my first project. Now I am able to understand somehow what exactly it's saying. So this is but there are some other errors that it was saying. This one was okay. Let me say what exactly the other errors were. Hopefully we will find it out. 1 2 is not. Where did I use the tool? Oh no, this was wrong. Yeah, it was supposed to be 0 1 2 and I did use the tool there. That's why the compiler was complaining. Okay, now I hope now we need an image. So I have some images in my home folder. I think it's in pictures. Yeah, just for testing this one, I'm taking this and go to here, Stego, okay, target, debug, and paste it here. And for Stego test, rename this image file to Stego test and try to rebuild it again. I hope this will work. Let us try. cd target debug, check it. Yeah, it is there. Stego test. So what we're going to do is we're going to make convert this stegotest.jpg as our carrier file. So once it's converted to carrier file, We don't before that I will show you what you have already seen that one, right? This is the content of the file. Just so it's nothing going to happen for human eye after this operation, I hope. If it works, like if it's going to make any runtime error, then we have to again work on this. Oh, it did, like so. We didn't do any differentiation on here, but it did for us. The hidden message is hide this for me. Yeah, both worked actually. We called the hide message using this. Here we manipulated the image, actual image, using the RGB LSB. Then we after that we use the same image. Like that's what I was saying in the beginning. The sender and receiver should have the same techniques. It doesn't matter they need to have the same tool, but the tool should be using the same algorithm of the sender. So when the sender is using the LSB algorithm, that definitely the receiver should have the LSB algorithm to extract the message. LSB algorithms reverse model to extract the message. So that's it. It's working. So let me check this one. See, this doesn't have any visible changes for a human eye, but this is a carrier file now. So you can try this in different formats, like even try to explore more with the audio, video, or other formats. This is the basics of Stego, and this is how we can try to develop steganographic tools. And in terms of red teaming or pen testing, how we can make use of it, it's not going to be a direct way of making use of this one. Definitely we can, maybe you can bypass some filters, initial filters, just by sending an image, by hiding your shellcode. But yeah, the second stage will be a bit different from the normal direct execution of DLLs loading or exe loading, because you have to extract this shellcode from this image and then you have to run the shellcode again. That is a huge process, but just it's up to your imagination how we are going to make use of this in real time. And again, this is going to be just an educational purpose research video, just to show how we can do this using Rust. And yeah, that's it for this video. This is the main thing I have planned, and I really thank all of you who are supporting me, because I just recently crossed 2000 subscribers, and I never expected that, because everybody was discouraging me when I was going through the programming series for hackers, because I think at least more than 50 or 60% of people in security, they don't like programming, or they are not interested to develop tools, because they have everything available now as free open source. So nobody is going to. But I strongly encourage this, because you should know what is happening behind the scene, or what exactly, or how exactly a tool is working. Anyone can make use of a tool. No, it doesn't matter. And this world of AI is very challenging. So anyone can make use of tool if you have time. You just spend some time to learn the parameters of or the GUI options of tools, and you can make use of that. The core concept behind this kind of, this series I'm planning is just to understand what exactly the tool is doing, or how exactly the tool is working. So I'm really happy that a group of people really like this kind of approach, and I really appreciate your engagement, and I hope you support in continuous series. And that's all for this series, and say bye from Alpha. See you soon with the next video.